Bismillah. Today we start chapter 2, database system concepts and architecture. This is the outline of chapter 2. Data models. First, let's go over the term data abstraction. Data abstraction basically means you only focus on the data that is needed to solve your problem and you ignore the rest of the details. So let's give an example. Let's say you're designing a database for BRAC University Student Management System. So you're going to store the data of BRACU students. Now, what kind of data does BRACU want to store about students? Information like ID, name, address, phone number, courses, grades, etc. What about information like height, weight, blood pressure? This information is not of interest for the BRACU authorities regarding their students. So we can ignore this data. Now let's say you're designing the database of LabAid Hospital and you want to store the data of the patients of LabAid Hospital. Now information like height and weight, blood pressure, this is certainly of interest to the LabAid Hospital. So for the same person, if you're storing the data as a student, you'll store certain data. And if you're storing the data of that same person as a patient, you'll store a different set of data. So this is what is meant by data abstraction. You suppress the details of the data that is not of interest, and you only highlight, you only focus on the essential features that is needed to solve your particular problem. That is called data abstraction. And data model is the way to achieve data abstraction. Definition of data model is a set of concepts to describe the structure of the database and certain constraints that the database that need to follow. So structure of the database means how many tables in the database, how many columns in each table in the database, what are the data types of each column. Constraints are basically conditions that the database have to obey. So example of constraints could be the student ID must be a number. It can only store digits, it cannot store string characters like A, B, C, D. Another example of constraint could be a student ID cannot be null or empty because every student must have a student ID. Another constraint could be student ID must be unique. It is not allowed for two students to have the same ID and so on. So these are examples of constraints. So data model is a set of concepts to describe the structure of the database and constraints of the database. Now data models can be divided into three categories: conceptual, physical, and representational. So conceptual data model is a high level data model which will describe the structure of the database at a high level that can be understood by the end users. Now the end users may not be technical people, they may not have a degree in computer science, but they still want to understand the structure of the database. For them, we have the conceptual data model, which will describe the database at a high level using English statements. Often, the entities and relationships are used in the conceptual data model. We described entities briefly in chapter 1. So, for a BRACU student management system database, entities could be student, course, section, faculty. Relationships could be student registers for a section of a course, student belong to department, faculties teach sections of course, and so on. So high level English like description of the database that can be understood by the end users. This will be in the conceptual data model. Then we have the physical data model, which will be a description of the database at a low level, at the physical bits and bytes level. So for example, okay, we'll store the student ID for a student. What is the data type of student ID? That's the integer. Okay. How many bits will be used to store the student ID integer? Is it an 8-bit integer? Is it 16-bit? Is it 32-bit? Okay, we'll store information of student name for every student. How many characters in the student name? the student name is a string, how many characters? Let's say 16 characters. Okay, each character, is it a ASCII character like for English, or is it a Unicode character for Bangla characters? So how many bytes will be used to store per character? This kind of bits and bytes information will be stored in the physical data model, and this low-level information will be used not by the users but by the engineers who will implement the data model in a particular computer hardware. So the engineers and the database administrators also, they will be making use of the physical data model, this low-level information, to implement the data model in a particular machine hardware. How many bits, how many bytes, and so on. And lastly, we have the representational data model, also called implementation data model. This data model, you can say, is a combination of the first two. It has concepts at the high level that can be understood by the end users. And representational data model also has information of bits and bytes that can be used by the engineers to implement the DBMS in a particular machine hardware. So the representational data model can be used both by the end users and also by the engineers for their implementation. And this representational data model is used by many commercial DBMS implementation in many commercial systems. Two terms that is important in a database is schema and state. So what is a database schema? Database schema is the description of a database, the description of the database structure, the data types, and constraints of a database. We often draw a schema diagram to illustrate a database schema. Let's take a look at the database schema diagram. So here we have the schema diagram of our BRACU University database. The schema diagram shows the tables that are in the database. So we have the student table. Table names are usually in all bold, all caps. So we have the student table, course table, prerequisite, section, grade report. And inside each table, what are the columns? That is also shown here. So in the student table, we have the student name, student number, class, major. So these are the 4 columns in the student table. In the course table, we have the columns, course name, course number, credit hours, department, and so on for each table. So the database schema shows you the tables in the database, and in each table, what are the columns in each table, that is also shown in the schema diagram. Also, if you want, you can show the data type of each column. Let's say in parentheses, you can say student name is varchar 20, meaning a 20 character string. Student number, let's say integer, int, and so on. If you want, you can also show the data type in the schema. Database state. The database state is the actual data that is stored in the database at a particular moment in time. Database state. So we can draw a diagram for database state also. Here is an example of a database state, again of the BRACU student database. Here we actually see the data that is stored in the tables in the database at a particular time. So for example, in the student table, we currently have how many students? We have 1, 2, 2 students. Each row represents a particular student in the database. So for example, row 1 in the student table is for a student whose name is Smith. His ID is 17. He is a first year student majoring in computer science. Row 2 represents a student whose name is Brown. His ID is 8. He is a second year student also majoring in computer science. And currently we have 2 students in our student table. In the course table, we currently have 1, 2, 3, 4. 4 courses that are being offered in the course table. The name of the first course, Intro to Computer Science. This is the course number, grade hours, department. This is the information of the second course in the course table, and so on. And for each table, we can see the actual data that is being stored in the tables of the database. So this is an example of a database state. Notice that in the database schema, only the structural information is shown, but no data is actually shown. So we don't know who are the students, what are the names. That is not shown in the schema, but that is shown in the database state. Here we can see who are the students, what are the name, ID, etc. Now, between database schema and database state, which one do you think changes frequently, and which one do you think does not change very much? The database state actually changes frequently, because anytime you make any change in the data in the database state changes. So if I add a new student in the student table, the database state will change. If I update the course name of any course in the course table, the database state will change. If I delete a section in the section table, again the database state will change. So any change in the database causes the database state to change. What about schema? The database schema should not change frequently. This is the structure of the database. This should stay the same. Rarely you may want to change the database structure, but in general, the database schema remains the same. It does not change frequently. If needed, it can be changed, but that is rare. But the database state is changing very frequently. So the database schema does not change much, but the database state changes frequently. We saw the definition of database state, the content of the database at a particular time. Notice that database state is a function of time, because as time is going, as the data changes, the content of the database changes, the database state also changes. And a database state should always be a valid state, meaning it should satisfy the structure and constraints of the database, all the conditions of the database. And when the database state changes, it should go from one valid state to another valid state. The database state should never become invalid. The database state should always remain a valid state.